Right, here's question 1. Now let's do a VT graph. Starts from rest, accelerates uniformly at 3x meters per second, reaches a velocity of 30, so that's 30. For t seconds, and then it decelerates at x, so that would have been better here. So this is at 300, and the whole area is 6,000 meters. The whole area is 6,000 meters. So if it's accelerating at x, then a over b equals x. Oh, sorry, at 3x, but this bit is x, so a over c is x. This time is t from there to there, so I know that t plus b plus c equals 300. So therefore t plus a over 3x, so it's plus a over 3x, and c is a over x, equals 300. A obviously equals 30, so I get t plus 30 over 3x, that's 10 over x, plus 30 over x, so altogether that's 40 over x, which is 300, as required. So we know the total area is 6,000, so let's work out the total area. This is 30t. This is half the base times the height, so that's 450 over x. And this is half the base times the height, so it's 450 over 3x, which is 150 over x. So all these numbers add together to make 6,000. So let's add them up. That's 600 over x plus 30t equals 6,000. But we also know that 40 over x plus t is 300. So let's write t is 300 minus 40 over x. And solve that equation. That works out to be t is 100 and x is 0.2. So now the distance it travels at constant velocity is 30 times t, so that's 30 times 100, that's 3,000. And the time from leaving A to reach the point halfway between the stations. Oh, hang on. I think we need another slide for that. So that area there is 150 over x, so 150 over a fifth is 750. So as the whole distance is going to be 3,000, then that area there has to be 2,250. But we know that's 30, so this is 2250 divided by 30. What's that? 225 divided by 3. That's 75. So that's 75, and this works out to be 50, so the total time is 125 seconds. Now let's look at question 3. This is solve that in 2 dimensions. That's 0. That's minus 10, because it says g is 10. It's thrown with that being 20 cos theta, cos alpha, and upwards is 20 sine alpha, minus 20 sine alpha because it's downwards. Now the horizontal distance they say is 9 meters, and the vertical distance they're saying is 10 meters. No, that's not right. It misses the target, so we don't know what this is, but we know that this one is 10. So let's use s equals ut plus half at squared here. It would make sense to take that as the positive direction, so we can get rid of those minus signs. That's better. So 10 equals 20 sine alpha. Well, sine alpha is 3/5 t plus a half a, that's 5t squared. So we need to solve that for t, and we get one positive answer and one negative answer, so it's 0.65, 2 sig figs. So now we can put this into s equals ut plus half at squared in the horizontal direction. S equals 20 cos alpha, so 20 times 4/5, that's 16, multiplied by 0.65. So that works out to be 10.4. So the distance from T to Q is 10.4 minus 9, which is 1.4. I made a rounding over there, so that's 10.45, so that's 1.45 or 1.52 2 sig figs. For part C we need to do some more of this. Yes, U, V, A, T. U is 20 cos alpha, which we worked out to be 12. Oh, let's go that way. And then in the vertical direction it's 20 sine alpha, that's 12, that's 16, that's 0, that's 10. And we know that A is on the path of the ball vertically above T. So the horizontal distance is 9. We want to find the speed at that point. Well, horizontally the speed is 16, there's no acceleration. Let's work out the time it takes to get to this point by using s equals ut plus half at squared. So 9 is 16t, so t is 9 over 16. So then let's do it this way. Let's use v equals u plus at. So v is 12 plus 10 times 9 over 16, which is 17.625. So the speed, you need to use Pythagoras on these two components, the 16 and the 17.625. Yeah, and that's 23.8.